Hello, my name is Laramie Pooser, and I'm going to be giving a presentation on the estrus cycle of cattle. Estrogen is produced by the ovaries, and it makes its way to the brain to start a signal cascade of hormones. Once estrogen reaches the brain, it interacts with the hypothalamus to generate the gonadotropin-releasing hormone, or known as GnRH, which then goes to the anterior pituitary gland to produce the follicular stimulating hormone and also produces the luteinizing hormone, or also known as LH. And the FSH and the LH then travel to the ovaries. Once the follicular stimulating hormone is produced by the hypothalamus, it makes its way to the ovaries where it makes a follicle form, and there is where the egg is held, and it almost kind of primes the egg for ovulation, and it also encourages the ovaries to produce estrogen to help prime for the possibility of conception. Then you have your luteinizing hormone. Once it leaves the brain and reaches the ovaries, it causes ovulation to occur, and this is when the egg ruptures from the follicle, and then that rupture forms almost a scar called a corpus luteum, and this corpus luteum then produces progesterone. And then it makes its way to the brain. If the egg is fertilized, progesterone is then produced from the corpus luteum located in the ovary, where it travels to the brain to tell the hypothalamus to stop producing GnRH. This allows the cow to maintain its pregnancy and not go into another estrus cycle and go into heat to be receptive again. However, if the egg does not get fertilized, the uterus produces a hormone called prostaglandin, and this hormone then travels to the brain and interacts with the hypothalamus, and this leads to the corpus luteum to regress and causes progesterone to decrease and to no longer be produced, and it goes into a hypothalamic clock, and essentially that means the cow will go into an estrus, they will not be receptive, and they go through a whole cycle all over again. Now we're going to focus on the follicle located within the ovary. So we have our follicular stimulating hormone, which obviously causes the follicle to develop, and that is located right here within the graph. And then once that follicle starts to form, obviously the luteinizing hormone is going to get stimulated and ovulation is going to occur. And ovulation occurs right over here. And you can actually see the egg right there being released. And then after that egg is released, the corpus luteum forms, which is located right here. This is where it starts to develop, and then this is when it matures. And this is probably most likely when it starts to really produce that progesterone, gets the brain really ready for trying to maintain a pregnancy and trying to get ready for the egg to be fertilized. And if it does get fertilized, it continues to maintain the pregnancy by producing the progesterone. However, though, if the egg does not get fertilized, we are going to have a regression of the corpus luteum because of the production of prostaglandin from the uterus due to the egg not being fertilized. And if you also notice one interesting thing, you notice the regressing corpus luteum is still like very close to the developing new follicle, and you notice it's all kind of happening all at the same time. It's not a step-by-step thing. As one thing's happening, another thing is also happening. So this is never a step-by-step thing. It's all intertwined and interconnected. Okay, so right before we end this presentation, we're going to touch on one more hormone, and this hormone is inhibin. This hormone is responsible for negative feedback for the follicular stimulating hormone. It is developed in the ovary, and it then travels to the anterior pituitary gland, where it blocks the generation of the FSH. However, this only works for FSH. It does not block the luteinizing hormone, only FSH, not LH. And this slide just has my sources listed, and this is where I got some information and also most of my pictures. Thank you for watching.